In this video, we are going to discuss what is called a radian. So to begin, what I want to remind you of is I'm not really going to use this formula below and the 2 pi. We'll talk about that here in a moment, but let's focus on this definition here. This is from high school geometry, and hopefully maybe you've seen it in Pre-Calc 1. But this is the circumference of a circle. A circle is 2 pi r all the way around. What a radian is, I'm going to look at the picture that's down here for a moment. I have a radius, so if I take a circle like I have it, and this is the center of my circle, they didn't really mark that, but the center of my circle, this r right here is the radius. What we're actually doing when we measure an angle like this, we still have a starting side, right, initial side, and a terminal side, but what we're looking for is we're actually taking this side here, let me highlight it, this side here, and we're laying it around the circle. And we figure out how many r's, how many radii, how many times can I lay the radius down? Like I would copy it, again here, and I would have like another point with another r, and then I would have another green one, and I would keep going around like that. And that's how I would measure my angle. So if I had like here is an angle like this, very small, then I would take this radii that's here, and I would figure out how much of it can I lay around the circle there. And this would be some kind of portion of r in that length that's there. So a radii is like just putting your radius on the edge of the circle and figuring out how many times it can go around. Well, if I take this formula, and it's kind of hidden in here, but the circumference of this formula is 2 pi r, or 2 pi radii, right? That's what that means, is what we're going to plug into r is we're going to say how many radii, right? What is the radius? So what this is saying is that for the whole length around a circle, it's always going to be 2 pi times whatever the radius is. So this actually answers a question for us. In radians, and this is true for any circle, I can lie around the r all the way around. That answer is 2 pi. I can fit 2 pi, whatever that means. I think it's like pi is like 3.14, so 2 pi, which is called tau, has another name, is 6.28. That is the length all the way around the circle. I can fit 6 radii around. So if we take a look at this picture down here, we'll fill all these spaces in. But if we look here, okay, so start, I'll highlight as I look at them. This is 1 radii, right? And then I have 2 radii, or radian, 1 radius. I can put a radius there, 2 radiuses, 3 radiuses, or radii. I guess radius isn't a word. Radii, and then a 4th radian, or the radius, and then a 5th, and then a 6th, and then some change. So it is about 6 point, like that number says at the top, 6.28. That's how many radians that we have in a full circle. So filling in some of these words here so you have them. 1 radian is the measure of a central angle of a circle that intercepts an arc equal to the length of the radius of that circle. That's exactly what we just said here. This is our central angles, right? Oops, I erased instead of circled. This is our central angle that they're talking about. This is the intersecting the arc, and then this is the arc itself. So a central angle is the angle formed at the center of the circle by 2 radii. Because the total circumference equals 2 pi, times the radius, a full circular rotation is 2 pi radians. We just discovered that up here, that I can lay 2 pi, which is about 6. Our circle or picture down here shows us that we can lay 6 of those radians or radii around the circle. All right, so this answers a few questions in radians for us. 1 full rotation, this is what we're going to be mainly working with in calculus. We use degrees for a lot of our physics, engineering type things, and then for calculus concepts, we use a lot of radians. So let's make our first, we're going to do a whole video on a bunch of these special angles, but here are a couple of the first ones. 1 full rotation is 2 pi radians. That's what we just talked about, right? So I can fit 6.28 radii around my circle. 180 degrees, well, 180 is half of 360, so half of 2 pi is 1 pi. And then we can cut the 180 again in half, a 4th of a rotation. Well, if I cut pi in half, I just get pi over 2. We just leave the pi, we don't actually get our decimals. So all the radians, most of the time, they don't have to be measured in pi, right? I could say, hey, my radian, this angle is 3, and that means that I can fit 3 of my radii around that angle. It doesn't have to have a pi, but most radian angles, most, not all, have the pi in their measurement. All right, so this is a great time to talk about what is called arc length, and we'll hit another section, another video here in, I think, like 5 videos. We'll hit that again, the arc length. But I want to go ahead and define it here. So an arc length is what we were talking about here, like the length of this arc. And we typically, I'm going to go ahead and give this to you. This is S. We typically call arc length S. This S thing is not going to go away. In Calc 3, we spend a whole chapter based talking about S and the way it changes when we spin. So that is the length of the curve along the arc of a circle. I will show you, like I said, in a few videos down the line, I will show you how to derive arc length. But as of right now, we know arc length is completely related to radians.